Today we discuss about pressure inside liquid droplet or air bubble. To understand this, first we understand why the liquid droplet or air bubble or soap bubble are spherical in shape. Because if we drop a water in any shape, then it try to acquire minimum cross section area and minimum surface area and minimum surface area in for minimum surface area for sphere, so it shape is converted into spherical shape. Now we understand the pressure inside a spherical shape by is more and how it is possible to understand. Suppose we consider a cross section area. Suppose this side pressure is P1 and this side pressure is P2, because line is straight, so P1 is equal to P2. If now we made a convex shape, then the pressure is P1 and pressure is P2. Now pressure P1 is more, so that it try to push it on the P side, P2 side, so pressure P2 is less than P1. Now take another case. In this case, P1, P2. Now pressure P2 is more, so it try to push on that side. So P2 is more than P1. So we understand any shape try to convert into spherical shape. For spherical shape, minimum cross section spherical shape has minimum surface area, and how pressure inside droplet is more than outside. Now we consider a case pressure inside a liquid droplet and air bubble. To understand this, first or pressure inside liquid droplet we calculate above the atmospheric pressure, because in that side and this side atmospheric pressure is equal on this side. On that side pressure P2 is more than, but pressure P1 is more than, but it is we calculate only above the atmospheric pressure. If we calculate with atmospheric pressure, then it will be a absolute pressure. I describe you absolute pressure in my last lecture. We understand by the how we calculate the pressure inside a droplet. Suppose we consider a cross section area in spherical shape and we cut into two parts. Now the pressure inside is more, but it is above than atmospheric pressure, so that the pressure will act on this cross section area, it pass by this section, and we take a projection this. Now the pressure force will be equal to pressure into pi by 4. Now we and the another force will be a surface tension force, and it will act in this way. Now to understand this, we consider a case that we take a football and we put a chewing gum on this football, and now this chewing gum will draw on all the sides of the football. Now this is like this it will like this, and on the back side, because we cannot see, so I will draw like this. Now if I cut these football into half part, then its cross section like this, and these are the surface tension. Now like this will act like this. Now it will act on the periphery of this, so the formula for the periphery like this. For equilibrium condition, we have to consider these two forces are equal. So the pressure is equal to 4 sigma by T. Now pressure inside a liquid droplet, because liquid droplet in liquid droplet one side is air and another side is water. So this is for the pressure inside the liquid droplet, but remember this pressure is above than atmospheric pressure. We have to calculate absolute pressure, then the formula like this. This pressure is above than atmospheric pressure, and this is formula for the absolute pressure. Consider another case of soap bubble. In soap bubble, the air is both of the side of the soap bubble, and the thickness of the soap bubble is very less. So we neglect the thickness of the soap bubble and take di, inside diameter is equal to outside diameter is equal to d. Now we calculated for the liquid droplets. So for this the case will be like this, because the pressure will act from this side and that side. So for liquid droplet we calculate this. Now for soap bubble this will add on this. So formula for the soap bubble will be 8 sigma by d. Now we consider another example. Let me take a liquid droplet. For this the pressure will be 4 sigma by d. Now this liquid droplet, let me consider water. So that the formula for liquid droplet like this. Now understand, please try to understand one thing. We have considered a case because in both side pressure is acting, so we take for case like this 4 sigma by d plus 4 sigma by d. If in this case suppose this is droplet and liquid in this side and outside is here, then the formula will be this. Suppose another case, now this is droplet and water is outside, because medium in this side outside, medium in this side inside, so formula will be this. Now for this case, because this is sign for water level, so that the pressure below the atmospheric pressure rho gh, so this formula will be like this plus rho gh. If we want to calculate absolute pressure, so P atmospheric pressure will also be add in this, so that the total pressure, or we can say absolute pressure for this case will be this. So this about the liquid droplet and soap bubble. Thank you. The another topic is pressure inside a liquid jet. For liquid jet, suppose this is liquid jet and this is coming out like this. So we cut this portion of this liquid droplet and put like this, so that atmospheric pressure is acting on this. Now the pressure force acting on this liquid droplet will be a pressure P, and this will be a, suppose this length will L and the cross section will be a D, because to calculate pressure force we consider a projected area. In case of machine design we also consider to calculate the area of the bearing. Also consider projected area to calculate friction forces, losses, power losses in machine design also. So in this case, we also consider a pressure force. For this, the area will be a projected area, and the another force will be a surface tension. To understand surface tension, I cut this like this. So after cutting this, this will be like this. Now please try to understand. I not consider a surface tension force on this part, also, because this area as compared to this area will be negligible. So we not consider this part and this part. So we have two area, because surface tension is act on the surface. The formula for the surface tension is force per unit length. Force per unit length. For this, you see my lecture, then you understand the surface tension force. Surface tension act per unit length. So cut, put. So this length will be L. So now surface tension acting on this part and this part. So formula for the surface tension will be this. Now for the equilibrium condition, these two cases and these two forces will be equal. Now PdL is equal to 2 sigma L. Now L get cancelled. Now the pressure force for a liquid jet will be this. Now today we studied three cases. Formula for the liquid droplet or air bubble. This formula for the soap bubble. This, and the formula for the liquid jet 2 sigma by D. Liquid jet, liquid droplet, air bubble, soap bubble, liquid jet. This formula, remember, this pressure above than atmospheric pressure. So these all about the liquid droplet, soap bubble and liquid jet.